This question is on vertical projectile motion. So whenever you are going to do questions on vertical projectile motion, what you need to do is to have the exam guideline. So from the exam guideline, you can see that you are expected as a learner to be able to explain what is meant by a projectile. That is an object upon which the only force acting is the force of gravity. You must be able to use the equations of motion to determine the position, velocity, and displacement of a projectile at any given point. You should be able to sketch position versus time graph. You should be able to sketch velocity versus time graphs and acceleration versus time graph. So the question we are going to look at would help us do one of those that we expected to do. So read your question. Very important to make sure you have understood what is expected of you. So a small disk C is thrown vertically upwards at a speed of 15 meters per second from the edge of the roof of a building with a height 30 meters. And they say after 0.5 seconds, a small ball B is shot also vertically upwards from the roof of the building at a speed of 40 meters per second in order to hit disk C. So that is the background information they give us to this question. And then the first question we get is to explain the term projectile. So like I said, projectile is explained here using our exam guideline. We just go to the exam guideline. We just use this information. An object upon which the only force acting is the force of gravity. Now they say calculate. The calculations come, the time that is taken by disk C to reach its maximum height. Okay, so if disk C is shot from this point, it is going to go up, then fall down. So for us to be able to calculate the maximum height, we are going to make the assumption that at its maximum height, it's not an assumption, we know at its maximum height, it has to stop. That means from that information only, we can calculate maximum height. Before you perform any of these calculations, I advise that you write, you communicate to the examiner to say you are taking downwards as positive or taking upwards as positive. So I'm just going to say taking downwards as positive. Remember why we are saying this, because we are dealing with vectors. We need to take into account the idea of direction in our calculations. So when we look at this question, I'm going to say initial velocity because it's shot upwards and I've taken downwards as positive. I'm going to use a minus 15 meters per second. And I'm going to say gravity or gravitational acceleration. I'm going to use 9.8 meters per square second since I've taken downwards as positive. And at its maximum height, the object stops. Therefore, the velocity will be 0. I've not been given the time that it takes to get to that point. So I'm going to say change in time and I'll put a question mark. Now this means I can use any of the equations that have these 4 variables and it should give me the answer. And the best equation is V final is equals to V initial plus acceleration, gravitational acceleration times change in time. So we can come here and say 0 minus 15 plus 9.8 times the time. So we now say the time is equals to, this is where we bring in our calculator. So bringing in the calculator, let me move the calculator this side. So with our calculator, we do our calculations. If we move this 15 to the left side, it becomes a positive. So I'm just going to say 15 divided by 9.8. That gives me a time of 1,53 seconds. So that is the time it takes for this object C to reach maximum height. Then the next question is calculate maximum height above the ground. So they want us to calculate maximum height above the ground that disk C would reach. So my advice is this question, you do it in parts. First of all, you calculate the maximum height that the object reaches above the building. Then you need to add the 13 to that maximum height. Many learners forget to do that, and then they lose marks. So we use orange and do that calculation. I can use this information that I'm given, the initial, the gravity, the final velocity, to calculate that maximum height. Or I can use an equation with time. Make sure that if you use an equation with time, if we got this answer wrong, then that means that also that other question would be wrong. But I'm pretty confident with the 1.53. So I'm just going to say change in y is equals to v initial plus v final over 2 times the change in time. So we come in here and they're saying the initial velocity 15 plus final, which is 0 over 2 times the 1,53 would give me the change in y. Here, remember, I'm not using acceleration or anything, so I'm just taking my upwards as a positive. So whatever answer I get here will be an upward motion. So 15 over 2 times our 1.53. Since we still have the 1.53 on our calculator right there, we can then just multiply this one by 15 over 2. Multiply it by 15 over 2. That gives us a distance of 11, 4. Sorry, let me get that calculator back again. 11,48 meters. 11,48 meters. So it reaches a height of 11,48 meters above this building. But the question asked you maximum height above the ground. So to give a final answer, you're now going to say 13 plus 11,48, and we give your final answer is 41,48 meters above the ground. Right, that takes care of that question, that one, and that one.